Hello again. Today's lesson is going to be the distributive property. It's 1.4 in your textbook. And here I have the distributive property kind of laid out for us. For any numbers A, B, and C, it means that if you have A times the quantity B plus C, that basically you have to distribute the A to the B, which is AB, and then the A to the C, which is AC. Also, that if you distribute backwards, you would get BA and CA. So these are, and it works for both addition and subtraction, so that's what the second line here is all about. And then we have some examples of how that works. 3 times 2 plus 5 would be the equivalent of saying 3 times 2 is 6, and 3 times 5, which is 15, and then 6 and 15 is 21. Or if you want to do it the shortcut way, then 2 plus 5 is 7, 3 times 7 is still 21. So this is just showing you with actual numbers how the distributive property actually works and why it's actually a sound property. But we want to do it or use it in more practical ways. So here I have a chart. I don't know if you can see the chart, but it's the University of South Florida Bulls baseball ticket chart. And it basically tells you these are the types of tickets you can purchase. And this is the cost of the tickets. So for an adult single game, $5. For a children's single game, so if you're 12 and under, it's $3. For groups of 10 or more, single game is $2. And for seniors 65 and over, a single game is $3. So the question says, a group of 7 adults and 6 children are going to a University of South Florida Bulls baseball game. Use the distributive property, and therein lies the key, to write and evaluate an expression for the total ticket cost. So the first thing we have to figure out is which kind of tickets are we going to be getting. Now obviously if you were just getting 7 adult tickets, then we would be in this bracket right here. But we also have some children, and children are in this bracket. So you might think that you'd have to take 7 tickets at $5 a piece and then 6 tickets at $3 a piece. But actually it says that since 7 and 6 is actually 13, we're actually going to be getting a group of 10 or more discount. So we're going to only be paying $2 a ticket. So the way that we're going to go ahead and write that out is to use the distributive property is going to be, we're paying $2 for the 7 adult tickets and the 6 child tickets, as opposed to paying the 5 and the 3 separately. We're going to pay $2 for both of those. So that would mean that we're going to have 2 times 7 and 2 times 6, which is 14 plus 12, which is $26. So that is basically using the distributive property to write and evaluate the expression for the total ticket cost. So what I would like for you to do now is using the same chart. So hopefully you wrote that down, or if you didn't, you need to write the chart down, because here we have another scenario where you have 3 adults, 11, and an 11-year-old, 2 children under 10 years, and same idea. So basically you want to use the distributive property to write and evaluate an expression that determines the cost of the tickets. So this is your do-it-yourself problem, and you can do that in your notes. All right, so then we also have another way that we can use the distributive property, and that is to use mental math. A lot of times we're asked to multiply things in our head that are kind of funky numbers. This is not that funky, but it's just to kind of give you an example of how you can use distributive property to do a problem that would probably be a little complicated to do in your head a little bit easier way. So what we're going to do is, it says to use the distributive property to rewrite 7 times 49. Now 7 times 49 might be a complicated number to multiply, but we know that 49 is the same thing as 50 minus 1. And so what we can do is we can rewrite this expression as 7 times 50 minus 1. And that is going to be 7 times 50 if you use the distributive property, and then minus 7 times 1. And this might be easier to do in your head because we know that 7 times 5 is 35, so you just add a 0 and you get 350, and then 7 times 1 is 7. And then it's a lot easier to do a problem like this in your head. Now, I don't know how many of you knew that 7 times 49 was 343, but when you do it this way, it's a lot easier to come up with the answer. So in a similar way, I would like for you in the do-it-yourself number 2 to take these 4 examples and to rewrite them in a way that would make it easier to multiply. So B might get a little tricky, but I will give you a hint. You can rewrite 2.5 as 2 plus a half. And then, yeah, so we want you to use the distributive property to rewrite each expression and then evaluate what the expression would be. So that's another way that we can use the distributive property. And then in the example 3, we are going to rewrite each expression using the distributive property, and then we're going to simplify our answer. So for this one, we are going to do 7 times 3w, and that's a minus, and then 7 times negative 5, or 7 times 5. And then 7 times 3 is 21w, and 7 times 5 is 35. And that would be my final answer, simplified. 21w minus 35. Sometimes, and we'll see that in the next example, sometimes when you simplify, you can actually end up adding like terms. But in this case, we don't have any like terms. This is a term with a variable in it, and this doesn't have a variable in it, so you can't add those together, so we just leave them like that. In this case, we've got 4 times 6v squared. We've got 4 times positive v, and then 4 times the 3. So we've got 4 times the 6v squared, this is a plus, and then 4 times v, this is a minus, and then 4 times 3. So now we're going to multiply this out, and 4 times 6 is 24v squared, and then we get 4v minus 12. And again, in this scenario, all of these terms are what we call unlike terms. They are not alike. Even though these both have a v in them, one is v squared and one is v to the first power, so that's not the same, and you can't combine them. So that's how you would leave your answer. So we have 4 examples for you to do here in the do-it-yourself part that you can do in your notes. And then I believe we have 2 more examples here. Okay, so example 4 is a situation where it's not like before where we had no like terms. We actually do have like terms, and I want to show you how we can use the distributive property to simplify these types of problems. So what we see is that these both have u to the 1 power, u to the 1 power. So we can use the distributive property and go 17 plus 25 and then times the u, like that. So it's almost like a backwards distribution, if you will. And so 17 plus 25 would be 7 and 5 is 12, so 20 and so 42 u would be our final answer for part A. And then in a similar way, we can do that with part B. Now in part B, we can't really do anything with the 6t squared, but we do have 3t and negative t, so what we could do there is we can go 3 minus 1 and then t. So the t has a 3 in front of it, this t has a negative 1 in front of it, so we can do that. And 3 minus 1 is 2, so, and again, because one is a t squared and one is a t, we can't combine those. So we were able to combine these two, but we can't combine the first term, which was 6t squared. And so our final answer is 6t squared plus 2t. So you have 4 examples to try on your own here. Remember that you can't always simplify it, so simplify each expression. If it's not possible, then you write simplified, that it's already simplified, so you can't go any further if it's not possible. All right, and then we have our last example, and in our last example, it gives us a phrase, a verbal expression, if you will, and then for part A, it wants us to write an algebraic expression that's going to replace the verbal expression, and then after I do that, they want me to simplify that and indicate the properties that I used along the way. So, twice the difference of 3x and y increased by 5 times the sum of x and 2y. And what we're trying to get you to realize here is that, you know, the way something is written sometimes is going to affect how you write the expression. Twice the difference. When we say difference, that means subtraction. And when you're subtracting, you have to subtract something from something else, which means that when you're subtracting, there has to be two things that are working there. So you have to be careful for that. So when it says twice the difference, I mean, obviously we're going to have a 2, and there's going to be a difference of something. But you have to have two things in order to have a difference. So we're going to look for those two things, and it tells us right here, the difference of 3x and y. Those are the two things that are going to be subtracted from each other. So 3x and y. So that's how you would write that. Twice the difference of 3x and y. Increased by. So increased by, we learned a couple days ago, is that you're adding to that. And it's increased by 5 times the sum of something. So sum means that you're going to do 5 times. So you have to take the sum first, and then whatever that sum is, you're going to increase it or times it by 5. So again, sum implies 2 parts, and you can see here that the 2 parts are x and 2y. So that is what that algebraic expression will look like. And so now that we've done the first part, we now have to do part B, which is basically asking us to simplify that expression. And we're going to use the distributive property to do that, and then indicate the properties that I'm using. Okay? So for the first part, we need the distributive property, which is basically going to mean that, and I'll just do it over here. We're going to say that that's going to equal 2 times 3x. Okay, so we're going to go 2 times 3x, and there's a minus, and we're also going to go 2 times y. And then we have a plus over here, and then we're going to go 5 times x. And then we have another plus, and then it's going to be 5 times 2y. And over here off to the side, I'm going to write the property that I've used, which is distributive property. Distributive property. Okay? And so now, for the next step, we're going to start simplifying. And the way that we're going to do that is we're going to multiply everything that we can. There's a lot of multiply going on. So we've got 2 times 3 is going to be 6x minus 2y plus 5x, and then 5 times 2 is 10y. So for our reason there, we're going to put multiply. And I hope that I have enough space. I'm going to move this guy out of the way up here for now and see if I can. So now what we want to do is we're going to use the commutative property of addition, because at this point we do have like terms. We have terms that have the same variable. We've got x's and x's, and we have y's here and y's there. But they're not in the right order. So the first thing we're going to do is we're going to use the commutative property to actually take those and write them in the right order. So we're going to take the 6x, and I'm going to change the order. So this is going to be now 6x plus 5x. So remember that the order in which we multiply doesn't matter. So that's the commutative property. So I'm going to put my 6x and my 5x together, and then we're going to get minus 2y plus 10y. So again, the reason for that is going to be commutative property of addition. So you can abbreviate that. That's a really long phrase there. And then we're going to use the distributive property, like we did earlier, to add the two like terms. So we're going to get, let's see here. We're going to get over here 6 plus the 5 and the x out here. And we're going to get a plus, and we're going to put a negative 2 and a 10, and then the y out there. So I put a plus here because I put the negative in there. So right here we're going to add the coefficients of the y, so negative 2 and the 10, and then the y over there. So this is going to be the distributive property again. Distributive property, and I kind of ran out of room, and I'm sorry about that. So we're going to put our answer maybe up here. Please follow me if you will. We're going to take this guy and kind of bring it up here. So our last step is that we're going to take the 6 and the 5, and we know that 6 and 5 equals 11. And then negative 2 and 10 equals 8. So our last step is actually substitution, because we are going to substitute, or substitution. Our last step is substitution because we're replacing the 10 and minus 2, that equals 8. So we're replacing it with 8 and replacing the 6 and the 5 with 11. So that's substitution for that very last step there. And I apologize again for this toolbar being in the way and for running out of space. But that is how we do this little guy. And so then we have one last do-it-yourself problem for you. And there it is. And once you've done this example, you will have completed this lesson, and we'll see you in class. Thank you.